We have identified that we are going to use the quadratic formula to be able to find the x-intercepts of a quadratic equation. And then we have in step 1 identified our A, B, and C of the quadratic equation. And now we're going to look at the discriminant. And so right here I have the full quadratic equation written out. But you'll notice I have just this part here in green. And that part in green is the discriminant. Notice that discriminant is underneath the radical symbol, but the radical symbol is not part of the discriminant number. So we are looking completely just at the value of this expression. Okay. Now, if you think about that expression, whatever that value comes out to be, we're going to take the square root of it. And that's going to lead us into 3 possible scenarios. Okay. When we calculate that discriminant number, what I had underneath the radical here in green, there's 3 things that can happen when you evaluate that number. It could either be a number that's greater than 0. In other words, we're saying a positive number. It could be equal to 0. Or it could be less than 0. And by less than 0, we are saying that that is a negative number. Those are the 3 possible things that after we plug in our values for the A, the B, and the C and figure out that discriminant number, the discriminant number can only be either positive, 0, or negative. Those are the only 3 choices. Now, those numbers, the results, are going to tell us a little bit about our quadratic equation. So let's start with if it is positive. So if we calculate the discriminant number and it is positive, what that tells me is that there are 2 solutions, or 2 roots, intercepts, x-intercepts, or 0 points. Okay? We don't know where they are located. We can have an intercept here and an intercept here, one here, one there. We don't know where they're located, but we do know that there are 2 of them. And so we know we're looking for something that looks like this, that has 2 x-intercepts. Okay. Now, let's look at the next possible. If it were, we calculate the discriminant and it comes out to 0, what that tells us is that there is only one solution. Now, the discriminant doesn't tell us what exactly that solution is, but it does give us an idea of what the graph looks like. So what that tells us is that there will only be one place where that parabola touches the x-axis. All right, let's look at the last possible one here. If we calculate our discriminant and it comes out to be less than 0, meaning it's negative, what we know is that our parabola never touches the x-axis. So it may look something like this, open up over here. It may look something like this, where it's open down and here. But what I do know is that there is no real solution to this. There's no x-intercept, there's no root that we can look at in the real number system. So what we know that it looks like is something that looks like this. It doesn't cross over the x-axis. So looking at the example here, x squared plus 5x plus 10 equals 0. We first need to identify our a, b, and c. And to do so, we need to make sure that this is set equal to 0, and it is. And so then I am going to say that my a is equal to 1, and that b is equal to 5, and that c is equal to 10. And at this point, I just want to calculate the discriminant. And remember that the discriminant is b squared minus 4 times a times c. And so I'm going to substitute in here and say that this is b squared. And we are saying that our b is 5. So 5 squared minus 4 times a times c. Okay, and then from there, this is up to you whether we want to do this mental math or we want to plug it into the calculator. So when we take and figure out our discriminant number here, if you're following order of operations, we'd have our 5 squared is 25, exponents first, and then if we do this multiplication, we'd have 25 minus 40, which is going to give us a negative 15. Now, what I would suggest that you get used to doing is just typing this whole thing into your calculator at one time. And if you need help with those steps, you can always come onto a Zoom call, and I'll be able to help you with how to put those into your calculator. Now, what this tells us is that this number right here is the discriminant. And the discriminant is a negative 15. And I know that I can't take the square root of a negative number. And so what this tells me is that there is no real solution to this problem. It never crosses over the x-axis. And so therefore, I can stop at this point, say that there is no solution. I don't need to continue on with the quadratic formula to be able to find the locations where it crosses over the x-axis, because it doesn't. As we go to find the discriminant in this problem, the first thing I need to do is identify the a, b, and c. And I notice that this is not set equal to 0, so therefore I'm going to have to take and set it equal to 0. I'm going to leave the x squared plus 8x there. I'm going to move this negative 16 over to the other side, and it is going to become positive 16. And I'm then going to be able to identify that the a is 1, that the b is 8, and that the c is 16. And so when I go to do the discriminant, remember our discriminant is b squared minus 4 times a times c, that I'm then going to be able to substitute in here and say that I'm going to have 8 squared minus 4 times a is 1 times c is 16. So I can go ahead and use my calculator. And what I'm going to do is find out that the discriminant is 0. And what that tells me is that I will need to keep going and go on to the next step in the quadratic formula. I now know, because this is 0, that there is one place, because I know the square root of 0 only has one answer, one solution, that this is going to somehow look like a graph that looks like this, with the key feature being that there is one place where it crosses the x-axis. So I would move on to the next step of the quadratic formula, which will be covered in the next video. All right, so I have x squared minus 11x minus 8 equals 7. So if I want to figure out the discriminant here, the first thing I'm going to need to do is set equal to 0. So I'll leave the x squared there, the minus 11x here. And then I'm going to need to take this 7 and move it to the other side. And it's going to combine with this other constant there, negative 8, and that's going to give me a negative 15. So remember that first step, set equal to 0. And then we're going to identify A is 1, B is negative 11, and C is negative 15. And so we're going to use the discriminant now to predict the number of solutions. There's our discriminant, and so now I'm going to substitute in. B is negative 11. Remember, substitute in, put those parentheses in there. Minus 4 times A is 1 times C is a negative 15. Now, if you are putting this into your calculator, this part right here, you do want to make sure that what you have is that is a parenthesis around that negative 11. Because what we want to calculate is negative 11 times negative 11, which is going to be 121. Okay. And then when we do this part of the multiplication over here, I'm going to have plus 60. And that is going to give us a discriminant of 181. Now, a positive discriminant tells us we need to keep going to the next step of the quadratic formula. Why? Because there are 2 solutions to this problem. And we would move on to the next step of the quadratic formula to find out exactly where those 2 solutions are located. Right now, all we know is that our graph is somehow going to look like this, with the key feature that there are 2 intercepts. Not sure where they're located. That's what the next step of the quadratic formula will tell us, and that's what's covered in the next video.